They expected the ocean and the jungle to be their allies, the heat and the distance to be weapons in themselves, and the calendar to be the strongest fortress of all. The plan in Tokyo rested on a simple conviction: even if American troops somehow took a beach, time would stop them. Time to clear wreckage, time to drain swamps, time to pour concrete, weeks, maybe months. And then the first morning after the first landings, somewhere in the Central Pacific, a Japanese observer looked through binoculars and saw something that did not fit any calculation. American fighters clawing into the sky from a strip of ground that, yesterday, was mangrove and coral. That sight rippled through Japan's command network like an electrical shock. The enemy had not captured a base, they had created one, almost overnight. The rumor spread before the reports did. It sounded like a myth. The Americans bring their airfields with them. The reality was more unnerving than the rumor. What stunned Japanese defenders across the Pacific was not a miracle weapon, but a system part engineering, part logistics, and absolutely relentless. The United States did not simply move along the map. It carried forward a factory for building war. Every assault task force included not only amphibious infantry and naval gunfire, but battalions of builders' bulldozer operators, pile drivers, surveyors, electricians, welders wearing Navy insignia and carrying the motto, "Can Do." They were the Seabees, naval construction battalions that landed in the early waves and treated a beachhead like a job site with incoming fire. Where a Japanese officer saw craters, they saw drainage problems. Where he saw soft coral sand, they saw aggregate. Where he saw jungle, they saw lumber, fuel, and shade for a repair line. To understand why Japan could not believe the speed of those airstrips, start with the Pacific's basic geometry. Nothing was close to anything. Fighters needed bases within a few hundred miles to protect convoys and support Marines ashore. Bombers needed longer, smoother runways to reach the next island and eventually the home islands. If building those runways required cement plants and months of curing, the offensive would crawl. American planners refused to accept that pace. Before a single landing craft touched a reef, engineers had drawn load plans for ships carrying entire airfields in pieces, steel matting by the acre, fuel tanks in knockdown sections, collapsible hangars, pre-cut timbers, generators, switchgear, and miles of cable. The Seabees rehearsed unloading sequences the way infantry rehearsed room clearing. LSTs would beach with bulldozers already chained at the bow doors, engines idling, exhaust sputtering as surf sloshed around the track shoes. The dozers were waterproofed, magnetos sealed, air intakes extended, exhaust stacks raised, electricals packed. When the ramps dropped, steel crawlers rolled straight into the water and pushed a path up the sand. Behind them came graders, scrapers, and trucks stacked with pierced steel planking, the famous Marston mat. That steel was the time machine. Each panel was a 10-foot by 15-inch strip of perforated steel with interlocking tabs. Each piece could be manhandled by a small crew, pinned to the next, and laid down over rough ground that had been scraped and compacted, turning soft coral into a runway strong enough for fighters and, given sufficient depth and care, even for medium bombers. Where concrete would need weeks to cure, steel needed minutes to lock. Where an airfield would once be the end of a campaign, it became the opening move for the next one. The method was brutal and fast. Survey stakes rose while mortars still thumped in the distance. The first objective was always a strip long enough for liaison aircraft and fighters, 2,500 to 3,000 feet if the terrain allowed, plus a short taxiway and a rough dispersal area cut into the brush. Drainage ditches came next. Pacific downpours could turn an airfield into a lake in one afternoon, and the Seabees learned to cut runoff paths as they built. Fuel lines snaked toward a tank farm of bolted steel cylinders perched on coral pedestals with earthen berms thrown up by the same dozers that had peeled back the jungle. By nightfall, if the fight allowed, floodlights on poles and on trucks would cast harsh white arcs over a geography that had already changed shape. And then it happened. The first American aircraft landed. Sometimes it was a light observation plane bringing a wounded Marine out under fire. Sometimes it was a fighter squadron, wheels touching down on steel that clanged and flexed beneath the tires, the pilots looking out over a brown rectangle that had been green just yesterday. To the defenders, who had counted on weeks of isolation behind surf and craters, that first landing felt like a trick of the eyes. It was not. Guadalcanal taught this lesson early. Henderson Field, battered and cratered when the Americans seized it, looked unusable to anyone who had never watched the Seabees work. They rolled crushed coral into the holes, leveled it, and stitched steel into place. Within days, Wildcats and Dauntlesses were rising from a runway the Japanese had tried to erase. That pattern repeated, faster each time. At Munda, on New Georgia, the Seabees hacked airstrips out of swamp and kunai grass under constant harassment. At Bougainville, they carved a runway from jungle and had aircraft operating while Japanese artillery still probed for the range. At Tarawa, where the reef, the tide, and the fire combined into a nightmare, construction crews went to work as soon as the lodgment was secure enough to breathe. Marines who had fought their way across the blasted coral looked back toward the beach and saw flatbeds and cranes rolling off LSTs, riggers slinging palletized matting to the ground, and dozers pushing berms as if this were a stateside job site with a slightly inconvenient climate. Within 24 hours, an airstrip took shape. That speed was not magic. It was muscle memory applied to a battlefield. The Seabees didn't simply improvise. They carried a cookbook for turning islands into bases. They knew how coral behaves when compacted moist versus dry, how to lay matting diagonally in soft patches to spread loads, when to cut drainage ditches deep, and when to leave shallow swales backed by brush. They understood that an airfield is a living system. If you don't give water a way out, it will take your runway with it. They learned to stage matting in ladder stacks along the intended centerline so crews could feed the front without hauling long distances. They cut dispersal bays into the bush aircraft didn't sit wingtip to wingtip. They hid under camouflage nets, engines ticking hot while ground crews dragged fuel lines across the matting and safety men kept cigarettes in pockets. Japan had counted on bombs to neutralize any field Americans tried to build. The Seabees counted on repair to beat bombing. The rule was simple. If a crater appears, fill it by nightfall. If matting buckles, lift and relay a section. If a fuel line leaks, replace the run. They staged pre-cut patch pieces near every active strip and trained crews to swarm a damaged panel with sledgehammers, pry bars, and pins, lifting, tamping, replacing. They anchored mat edges with pickets, backfilled voids with coral, and rolled with whatever they had, sometimes a proper roller, sometimes a truck towing a dead engine block. Ground crews learned fast that you could land a fighter on a strip that looked like a patchwork quilt as long as the seams were tight and the water had somewhere to go. The Japanese command realized too late that the enemy's critical delivery was not just a division of Marines, it was a kit of parts. Tank farms in knockdown crates bolted together like children's toys and rose into fuel depots behind earthen berms. Prefab Quonset huts became maintenance shops within days. Portable radar units sprouted on knolls above the field, their cables running to generators sitting on skids ready to be dragged if the line crept forward. Ordnance magazines grew from revetted pits lined with sandbags, with shell hoists cobbled from timber and steel. The noise never stopped. Dozers growling, winches whining, hammers clanging on matting, a rhythm that meant tomorrow's sortie rate would be higher than today's. When the Marianas fell into the plan, the tempo became breathtaking. Saipan and Tinian were not just stepping stones, they were canvases for a new scale of runway long, wide, and strong enough for the B-29 superfortress. The Seabees did not wait for perfect conditions, they created conditions while the fight still echoed in the hills. Coral quarries opened the same week the beachhead stabilized. Steamrollers and graders turned crushed coral into a base course. Where soil was volcanic ash, they layered matting over an engineered foundation to prevent pumping and rutting. Taxiways radiated like spokes to dispersal hardstands, and revetments grew from earth thrown up by the same machines that had cut the strip. In Japanese planning tables, such work would consume months. In reality, by the time Tokyo received the first detailed report, American bombers were already testing weight and torque on the new surfaces. The technical tricks multiplied with experience. On atolls, the reef itself became a construction material. Bulldozers clawed up coral heads, dumped them into low areas, and compacted the mass until it behaved like a primitive concrete. If a tide ran too high for comfortable unloading, pontoon causeways solved the problem. Floating roadways, lashed from steel boxes that turned surf into a driveway. If a lagoon offered calmer water, crews cut a short strip on the lagoon side first to receive seaplane tenders and utility aircraft, then swung resources to the ocean side for the main field. If a storm threatened, fuel and ordnance went into revetments, matting stacks were lashed down, and equipment was parked in V-shaped hides to break the wind. None of this looked like glamour, which is exactly why it worked. The Japanese officer corps prized elegant plans and heroic stands. The Seabees prized checklists. An airstrip is dirt, steel, drainage, and schedule. Get those four right, and everything else becomes supportable. The most sobering truth for Japan was that American airstrips did more than launch aircraft. They collapsed the calendar between battles. As soon as fighters flew from the new field, they extended the radius within which the next landing could happen under cover. Patrol planes ranged farther, submarines received better reconnaissance, and transports ran with less risk. Every hour an island strip stayed open multiplied the pressure on the next island along the chain. Time, the fortress on which Japan had bet, was being stripped for parts and sold for speed. The psychological impact radiated outward. On islands where Japanese soldiers had been told that engineers would keep Americans grounded for weeks, a string of contrails appeared within days. Civilians who had believed distance made them safe heard the drone of engines from a field built behind yesterday's front line. Pilots who had planned raids against exposed transport fleets found themselves intercepting fighters that were already airborne and already closing from unexpected directions. The message was not subtle. If the enemy can carve an airfield out of jungle in a few days, nowhere beyond a few hundred miles can sleep. There was a human engine behind the machines. Seabee companies were packed with men who had poured highways, laid pipelines, and erected steel frames in peacetime. They brought the culture of deadlines to the tropics and shaved those deadlines under fire. They learned quickly to work by torchlight with blackout discipline, to set a panel with 3 men when 5 were tired, to rig a dozer recovery with a sling and a prayer when the tide pulled wrong, to keep crews rotating through shade and water so the job did not stall in the heat. Their officers measured progress in runway feet per hour and judged success by the first safe landing. Marines and soldiers started betting cigarettes on the moment the first plane would touch down. The wagers got closer with every campaign. The obvious question, how did Japan not anticipate this, has a hard answer. They saw pieces, but not the system. They understood a landing strip as a location. Americans understood it as a procedure. Japanese reconnaissance reported matting. Staff officers dismissed it as a convenience for muddy taxiways. They noted bulldozers. They did not imagine those dozers arriving in the first wave and driving off a landing craft into 3 feet of surf. They knew Americans had engineers. They did not grasp that those engineers would set graders in motion while the beach was still being registered by hostile artillery. The defenders prepared to crater fixed runways. The attackers showed up with a runway kit and men who could make it function on ground that had not existed at dawn. There is nothing mystical about turning coral and steel into a flight line, and that is what made it terrifying. It could be done anywhere there was enough flat land to scrape and enough hands to keep the panels moving to the front. The Seabees taught pilots to aim for the center of the matting and keep rolling. Breaking too hard on fresh coral would tear up the surface. They painted guidelines overnight, sometimes with swabs and thinned-out paint if brushes were scarce. They put up windsocks made from canvas, cut off damaged tents. They improvised arresting gear by anchoring cables if a short strip had to catch an overloaded aircraft. They set up portable beacons, long-range HF radios, and later ground-controlled approach sets that gave life to the strip in bad weather. The airfield was never just an airfield. It was a package: power, fuel, ordnance, weather, comms, crash and salvage, transport, tents, kitchens, water points, latrines. By the end of the first week on a new island, mess lines wound through a town that had not existed 10 days earlier. Japanese units learned to dread the throb of generators as much as the bark of naval guns. That sound meant the runway was not a fluke. It was plugged into a grid. Every time Japan tried to reassert the old rules, pound the strip at night, send raiders at dawn, the response was faster. Potholes filled before noon, bomb splinters were swept, panels swapped, lines repressurized, aircraft back on the schedule. The clock that the defenders had counted on kept being reset by men with sledgehammers and a roll of pins. What began as disbelief hardened into a strategic problem Tokyo could not solve. The garrison on one island might bleed the invaders for a day, but by the second day, those same invaders were flying cover for supply ships in reconnaissance for the next landing. American airstrips did not merely enable operations, they collapsed space. The map shrank campaign by campaign until bases built from coral and steel ringed the home waters. The lesson came with a cold edge. If your enemy can build an airfield faster than you can destroy it, your outer defenses are not a shield. They are an early warning. The irony is that nothing about the process looked grand. There were no marble arches, only steel with holes in it. There were no speeches on the runway, only hand signals and ground crew shouts, and a battered sign that said, "Keep 'em flying." But for Japanese officers who had believed that geography and distance could be counted like divisions, the sight of a fresh strip gleaming under Pacific sun within days of a landing forced a new arithmetic. The Americans, they realized too late, did not invade an island. They installed a forward operating system, one that could be assembled in pieces, repaired faster than it could be harmed, and copied again on the next patch of ground. That is why the disbelief ran so deep. It wasn't that an airstrip appeared where none had been. It was that once it appeared, the clock for the next one had already started.